This video is going to review the vocabulary words of prime and composite numbers and show you some strategies that you can use to tell whether a number is prime or composite. So first of all, let's review our two vocabulary words. Remember that a prime number is a number that has only one factor pair. Another way to say that is a prime number has only two factors, one in itself. We know from the identity property of multiplication that every number has a relationship with the number 1 because any number times 1 is that number. So we can see here that these numbers all have only one factor pair. Okay, there's no other way to take whole numbers and multiply to get any of these numbers. The other vocabulary word is composite number. So a composite number is a number that has more than one factor pair. Again, meaning it has two or more, it has more than, not just two, it has more than two factors. So you can see with the number 4, there are two factor pairs, two factor pairs for 6, two factor pairs for 8, 2 for 9, 2 for 10, 3 for 12, and then I could keep going on. So one thing that I do want to point out is the number 0. 0 is not actually a number. 0 is a placeholder. It's a placeholder telling us there's nothing in that place value. So 0 is not a number, so it can't be prime or composite. Well, also the number 1 is a special number because if you look at this, I know that if I'm talking about the number 1, that there's not more than one factor pair to make the number 1. So if I think about whether a number 1 is prime or not, again, I have to have at least one factor pair, okay? 1 times itself. But technically, 1 times 1 is not a factor pair because I have to have two different numbers. And so the number 1 is not prime or composite. It's a special number. It's not either one of those. I do want to point out the number 2. The number 2 is a prime number. It is the only even prime number because it only has one factor pair. Every other even number, so 4, 6, 8, 10, and so on, is going to be composite. 2 is the only even prime number. Now, a lot of students say that all odd numbers are prime. And I could see how they might say that because look at these. 3, 5, 7, 11, and 13 are all odd numbers, okay? There are a lot of odd numbers that are prime, but not every odd number is prime because remember the definition has nothing about whether it is prime has nothing about whether it's odd or even, okay? We're talking about how many factor pairs. So if I go back to this definition of composite number, look at this number 9. 9 is an odd number, but 9 has two factor pairs. Okay, so that's more than one, so it's a composite number. If I have the number 15, okay, I don't have that on this list, but 15 can be made with 1 times 15 and 3 times 5. So therefore, 15 would be an odd number, but it would also be considered a composite number. So that's a breakdown of the vocabulary words. Now, there's two strategies that you will want to use this year to tell whether a number is prime or composite, okay? It just depends on what you have available to you. So some of you might have some things at home that you could use as a math manipulative. Okay, you might be able to make some arrays. Some of you will not have math manipulatives and you'll want to use a multiplication chart. I'm going to talk about both of those. So here I have arrays for the number 12. Okay, remember that an array is a square or a rectangle. I can't have a strange shape like this and call that an array. That is not a square or a rectangle, so this would not be an array. But if I put it back here, now it's an array because this is a rectangle. So all three of these are rectangles. Well, if I look at this, there's 12 times 1. If I look at this array, this is a 6 times 2 array. And then this is a 4 times 3 array. So if I have 3 arrays, that means that I have 3 factor pairs. Every array is a factor pair. So if I'm looking at 12 and I build these different arrays, I can see that I have 3 factor pairs, which means that I have 3 arrays. Okay, so then 12, based off these manipulatives, is for sure a composite number. All right. The other way that I can tell if a number is prime or composite is to just use my multiplication chart. So if I start looking at my multiplication chart, and let's say I want to prove whether the number 6 is a prime or composite number. Well, I'm going to start looking. I have my different columns colored because I like columns. Remember, you can go to the side too. It doesn't really matter. Okay, remember this row right here is the same information as this column. Okay, so I see a 6 right here. And that means that 1 times 6 makes up 6. I also see a 6 here. And that means that 2 times 3 is 6. Now, I see a 6 here and a 6 here, but this 6 is 2 times 3, which I already said 3 times 2 is 6. So technically, 2 times 3 and 3 times 2 would be the same factor pair. It doesn't matter if you switch them around or not. But I do have 1 times 6, and I have 2 times 3. So that tells me that there are 2 factor pairs for the number 6. Okay, I can look here. 1 times 12 is a factor pair. I see 12 again, and that's 2 times 6. And I see 12 again, that's 3 times 4. Now remember, 3 times 4 is going to be the same as 4 times 3. So sometimes when you're looking at your multiplication chart, you should write it out off to the side so you know that you're not having repeats. So for instance, if I'm looking here at the 12, I would write it out like this: 1 times 12, 2 times 6, 3 times 4. Because then if I look at my chart and I go, oh, well, 12 times 1, well, 12 times 1 is the same as 1 times 12. 2 times 6 is the same as 6 times 2. 3 times 4 is the same as 4 times 3. That's the same factor pair, okay? It's not a different factor pair. So I can use either one of those. I can use my multiplication chart or I can use arrays. So I am going to take a couple of numbers and I'm going to use both strategies to solve whether these numbers are prime or composite. So first I want to think about the number 8. Well, I made the arrays for 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8 by 1 array. So I can say 1 times 8 for this array. Then I was able to make, oh no, I lost the other part of my array. Here it is. I was able to make this array for 8. So there's 1, 2, 3, 4, 5, 6, 7, 8. This is a 1, 2, 3, 4, and 1, 2. So I can either label it 2 times 4 or 4 times 2. So I can see that the number 8 has 2 arrays. Since it has 2 arrays, this would be a composite number. Okay, looking at my multiplication chart, I can prove that. Well, this says 1 times 8, and I see 1 times 8 right there. And then this factor pair says 2 times 4, and that's true. 2 times 4 is right there. So I know for sure that 8 is composite. The next number I want to prove is 5. When I made an array for 5, I had this, sometimes we call them, when they're like this, we call them a train. So I had this train. 1, 2, 3, 4, 5. Okay, so I know 1 times 5 makes 5. Well, I was playing around with it and I was trying to see if I could make another square or rectangle. But I can't because I keep coming up with weird shapes that are not squares or rectangles. And so because of that, I only have one array. So 1 times 5 is the only array. And if I look here at my multiplication chart, the only 5s that I see are right here and right here. Well, remember this one right here is 1 times 5. This one right here is 5 times 1, which is the same factor pair. So there is only one factor pair for the number 5, so 5 is prime. So now looking at the number 4. Well, I was able to make a train. 1, 2, 3, 4 by 1. So that's 1 times 4. I was also able to make a square. 1, 2, 3, 4. This is a 2 by 2. 2 times 2. So since there are 2 arrays, 2 factor pairs, 4 has to be composite. So let's double check. I see a 4 here, which is my 4 times 1. I see a 4 here, which is my 1 times 4. And I see a 4 here, which is 2 times 2. Now remember, 1 times 4 and 4 times 1 is considered the same factor pair. So that tells me that 4 is a composite number. And also, because of the fact that 4 is even and it's higher than 2, then I know it's composite. Now remember, that doesn't work for odd numbers, but for every number, every even number that is greater than 2 will for sure be composite, because then it's divisible by 2. And finally, I want to prove whether 3 is prime or composite. So I made this array, 1, 2, 3. So this is a 3 by 1. So 1 times 3. And again, I was trying to make a square or a rectangle, but all I kept coming up with was this shape, and it just wasn't doing anything for me. There was no other square or rectangle. So that means that only the train that I have, that's the only way to make an array for 3. So proving that on my multiplication chart, I only see 2 3s, right here and right here. Well, this one is 3 times 1. This one is 1 times 3. And remember, that's the same factor pair. So I only have one factor pair for the number 3. So that means that it is a prime number. So your goal today is to tell whether numbers are prime or composite, and to tell what factors they have. So for instance, if I get a random number, okay, let's say I get the number 18. Okay, and I want to tell whether that number is prime or composite. Okay, so I have a couple of things I can do. So first of all, I know that 18 is an even number that is greater than 2. So right away, I'm going to guess that it's a composite number, but I have to prove it. So I'm going to look at my chart, and I'm looking for the number 18. So I don't see an 18 in my first column, but looking at my second column, I do, right here. Well, that's 9 times 2. So I'm going to write that down so I don't forget. I know that 9 times 2 is 18. And also, I forgot one important one, because remember, every single number has 1 in itself as a factor pair, okay? So looking at my chart again, I'm looking for 18, and there I have one. That's 6 times 3. Okay, I'm gonna look again. I don't see any 18s there. Just quickly scanning. Don't see any 18s until I get here. That's 2 times 9. But I already have 9 times 2, and that's the same factor pair. So I don't write 2 times 9 because I have 9 times 2. So if I'm looking again, I don't see any more 18s. But I can tell through here that there are 3 factor pairs. And remember, if there's 2 or more, it's composite. So this right here is enough of a proof to say that it is a composite number. Now, if I want to, I can take manipulatives and I can start making trains, okay? And I can see, this will be a really long train because that's already 10. 11, 12, 13, 14, 15, 16, 17, 18. So this is a really, really long train, okay? Can't even get it all on the video. So this is 1 times 18, okay? Then I could build my 9 times 2. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 9 times 2, okay? And I could do my 6 times 3. So here's, let's see, let's use this one. So 1, 2, 3, 4, 5, 6. Okay, so then I need another row here. Okay, so now this is my 6 times 3. Now, if you have something at home that you could use as a manipulative to build your arrays, awesome, you can do that. A lot of you don't though. And even if we were in school, we might not have enough for everyone to do these arrays, but you could draw them if you wanted. Okay, and I can just do this, label it like that. And then 9 and 2. I should do this. Let's see, so each one of those would need 6. Okay, and then I could do my 6 times 3. 6 times 3. So you can draw arrays as well. And remember that all arrays need to be either squares or rectangles. So now you're going to go ahead and practice this with Mrs. Higby.